Hey folks, Mr. Dell here. We are looking at interpreting a box plot. So if you remember what box plots are, this is what a box plot looks like. And normally what we would have is a set of data. And with that set of data, then you use it and find certain aspects of a box plot to plot the data. So I'm going to explain that as we go and answer these questions. So in order to kind of explain a box plot a little bit more, we're taking this problem from CPM course 2, section 7.8 7.1.8. Okay, so let me say that again. 7.1.8. There we go. And specifically number 7-95. Okay. So it says Elvin found a box plot in the school newspaper, and here it is. It is data that what is giving information about the number of hours spent watching TV each week. So part A, based on the plot, what percent of students watched more than 10 hours of television each week? Well, here's what's nice about a box plot. If you remember, what we would do is you'd have all this data, all these numbers. So we'd put all the numbers, whatever the numbers are, in order, right? I put all the numbers in order and just whatever they are, just put all the numbers. I don't know what the numbers are that I have. Okay. I know one of the numbers is 0 because that is always your lowest, your range, your lowest number. And then up here would be your highest number. And that looks like maybe that would be 21. So I know the lowest number would have been 0 and the highest number would have been 21. And then from there, what you do is you find the middle of the data, which once it's in order, the middle of the data, and we call that number the median. The middle of the data is called the median, and then the middle of the data goes here. So I can tell you the median is 5. So that middle number would have been 5. And then you take the rest of the numbers and you now find the middle of the middle, right? So, the middle of each set. So the lower quartile, which is this number, the lower quartile would be the middle of the bottom part of the data. So, and for example, if this is all the data I had, then that number there would be the middle. And so that would represent this number here, which is, let's see, 1, 2, 3. So that would be 3. So the lower quartile is the middle of the bottom half. The upper quartile, which is this right here. So let me write that. Lower quartile. Upper quartile is the middle of the top half of the data, right? Whatever it is. And I only have 7 pieces of data here, but this honestly could have 20 pieces of data, 30 pieces of data, but it just, I can't tell by what we have. So that would be the upper quartile, which is that number. And in this case, looks like that was listed as 10. So now let's answer this question. Let's go back to the question. It says, based on the plot, what percent of students watched more than 10 hours? So 10 being the upper quartile, if I'm talking about what percentage of data is this way, well, if you notice what I did is I cut this up in fourths. This is the fourth of the data is here, another fourth of the data is here, another fourth of the data, another fourth of the data. You know that basically from here to here is 25% of the data. From here to here is another 25% of the data. In this little spot is also 25% of the data. And then right here would be 25% of the data. So each section on a box plot represents 25% of the data. So that being said, what percent of students? We know that's 25% of the students are greater than. So we'll answer that right here. So 25% is what I have for A. B, based on the plot, what percent of students watch less than 5 hours of television? So at 5 hours, what percent is this direction? Well, it's 2 25s, which is 50%. So we can answer that by saying 50%. And then it says, can Elvin use the plot to find the median, or excuse me, the mean, the average? Remember, mean means average. And number of hours of television students watch each week. If so, what is it? Explain your reasoning. Well, in order to find average, remember to find average, you add all the numbers. Average is add all data. And then what? And then divide by the number of numbers, right? The number of numbers. So that's how you found average. Well, the problem is I don't know the data. I only have 1, 2, 3, 4, 5 data points. I only really know 5 of the numbers. Knowing 5 of the numbers is not going to give me enough to know the average, because I could take those and the average of those 5. But what if there's a lot more numbers in here? That's not going to give me a good clear. So we cannot find the average. So you cannot find the average because you do not know the data. So you would write that for C. You cannot find the average because you do not know all the data points. Last one, D. Can he use the plot to find the median? Well, yes, actually. Why? Because the median, as I said, when you do a box plot, the median is the middle number, and that's what goes in this line. That right there is the median. So can he use the plot to find the median? Yes. So a box plot shows your median. Okay. Yes, it is 5 hours. So the median is at 5 hours. It's the middle of the data. Okay. There you go.